So let's start with the definitions, and the definitions are, as usual, provided particularly by the Directive 98 of 2008. It defines two different words, two different expressions that are collection, that is the gathering of waste, including the preliminary sorting and preliminary storage of waste for the purposes of transport to a waste treatment facility. And the second definition is separate collection, that is the collection where a waste stream is kept separately by type and nature so as to facilitate a specific treatment. So the collection means something that is even farther than, even beyond the simple collection of bins that we have on our streets, but includes also our preliminary storage of waste in order to transport them to waste treatment facilities. There are, in general, some steps. There is not only one step of collection, since there are different players that have a role in the collection. Because generally the collection means something that must be implemented with a certain qualification of the different categories of waste in order to have them quite separated. If it is impossible to separate at source, so the separate collection means that the single citizen, single users try to keep the different materials separated, the separation must occur afterwards in general if we wanted to recover a significant amount of materials. The aim of the separate collection is, again, the best valorization of waste. So this could be recovery or reuse and recycling, the type of valorization. In the articles 10 and 11 of the same directive, recovery and reuse and recycling are introduced by saying that to facilitate or improve recovery, waste shall be collected separately if technically, environmentally, and economically practicable, and shall not be mixed with other waste or other materials with different properties. I inserted this definition, even though it is related to recovery, in this chapter of separate collection, because it is expressed the real aim, the real target of the separate collection, that is to try to facilitate or improve the recovery. If there are some conditions to be satisfied, if technically, environmentally, or economically practicable. The same expression is used also in Article 11, when reuse and recycling are introduced. Member States shall take measures to promote high-quality recycling, and to this end shall set up separate collections of waste, again, where technically, environmentally, and economically practicable and appropriate to meet the necessary standards for the relevant recycling sector. In this particular article, also some specific waste types are specific waste types are listed: paper, metal, plastic, and glass. By 2015, separate collection of these different categories of materials must be realized. We know that nowadays we have added some other materials that must be separately collected. For example, textiles, whose starting date for the separate collection was the 1st of January of this year. But I think that not in all the member countries, this separate collection has been implemented, at least in Italy, has not been implemented. Is it a new initiative, this kind of separate collection of the waste? It was curious to find this news some time ago. A horse and cart is used to collect the recycling in the Saint-Prix area in France. Okay, with a horse and yes, a sort of cart. But it was very similar to those devices that were used in 1884 by a man whose name was Poubelle, that introduced in Paris 3 separate containers for household waste. It is interesting to know that Poubelle is also still now the name of the separate collectors, the separate collection of waste in France. So this man gave his name to a sort of system of collection, since he was probably the first person that considered this kind of utility. Obviously, the different collection, the separate collection on those years were related only to perishable items, to paper and cloth together, to crockery and shells that were probably the most inert materials. But the type of collection was effective. Probably we know different types of waste collection system. It is strictly related also to the type of users or citizens that must be served by this kind of collection, and also the origin and the characteristics of waste. For the correct choice of the most suitable collection system, we may take into account the different technologies, vehicles, circuits, containers, and which are, after the collection, the waste treatment facilities that we have at our disposal. If we wanted to list some different waste collection systems, probably it is not a complete list, but they are the most diffused ones, types of waste collection systems. We may say collection of mixed waste, that is the most traditional one. Obviously, it is the easiest one from a managerial point of view, because you may have only one truck that is used to collect the waste in different roads. Separate collection of recyclable waste in appropriate containers. That means that you may have different containers, different bins, colored in different ways or with different various labels over the walls of the containers that indicate to citizens which type of material must be collected inside. Doorstep collection, that is also qualified as door-to-door collection. This means that the collection occurs with the services that passes besides every single house, collecting waste that is generated by single house. Public or private waste collection, that is particular types of waste, as well as, for example, on-call collection that is limited to bulky waste. If one wants to dispose of a fridge, something that could be very big, could call a collection service and leave the material on, for example, on the street, besides the street. Collection of public or private wet and dry residues, bring point systems, community depots, that is, that are some areas very well identifiable, to which the citizens could put their waste, and there is a separate collection inside this area, but the system is the citizens that must move towards a central station instead of the service that passes through the houses and the streets, the city streets. So if we want to understand what could be the most sustainable system, we always must take into consideration the three different main issues that are related to the sustainability, that are environmental, economical, and social issues. And in particular, environmental issues that could be related to the waste collection. Surely, there could be the aim of reducing the disposal of municipal solid waste and to valorize as much as possible the different materials that are collected. This could be the main aim. And to reach this aim, the highest percentage of separate collection would be achieved, because we have seen last time that if we have a mixed waste, we have a high entropy related to the system, and we must consume a lot of energy to reintroduce order in a largely entropic system. So if we have exhausted a high separate collection, probably we would need much lower amounts of energy materials, but probably a high amount of separate collection is not sufficient to guarantee, to assure a high purity of materials that we want to collect, because in some cases people are not aware about the differences among the materials that they have to put in the different bins. So they wrongly put some materials in a bin that is not the more appropriate. So in general, the purity of materials would be linearly related to the percentage of separate collection. However, these are the main environmental issues: to reach the highest percentage of separate collection in order to reduce the municipal solid waste disposal, and by increasing the purity of materials, obtain a higher valorization of each waste. There must be, we must also consider social issues, however, that are related to the waste collection systems, that are customer satisfaction. Again, usually the collection systems are provided by municipalities, public administrations, So they usually are they are quite worried about the consumer customer satisfaction, because the customers are, in this case, the citizens that could vote. Okay, and so if they wanted to keep the consensus, they must try to satisfy as much as possible the expectations of citizens. Availability of the different services, so as the citizens could dispose of their waste quite in comfort. Reliability and the equity of the service. It must be provided to all the people with the same degree of satisfaction. But we consideration also economical issues, because in some cases they are the barriers development of the most effective techniques or practices of waste management. For example, costs of collection and of general management, revenues related to recovered materials. We have seen last time that we may gain money if we have well-separated materials, because we can sell them to the transformers and pay some money from this change. Otherwise, if we have a highly mixed waste, probably we have to pay someone to dispose of this waste, generally in terms of landfilling or incineration, or something that is not the most effective way to valorize them. So there are, as usual, three different types of consideration to do. However, we may also the different separate collection systems from different perspectives. Particularly, if we want to consider the burden, the load that the operators of the public collection system could have, we must take into consideration what they have to do with the situation, taking into account the three main, the most common conditions that we could meet. For example, doorstep collection, door-to-door collection, street or bring point systems, a community depot, something that a central area of collection. In the first case, we have the houses that must be reached by operators of the waste collection system, so they may do a very long travel to collect all the waste from the different households. If we have a street container system, probably the grouped houses that live near to one another could have the same bin, the same container, so the truck that must collect all the waste may perform lower routes and obtain the same amount of waste. Finally, the bring point system could be the most comfortable for the public operators who haven't to do anything that is different from taking all the waste that brought to the bring point system by the users and transport it to. We see the same problem from the point of cities, probably surely the most comfortable system is the doorstep collection, because they usually do not have to use the car to put the waste in the collection points, while in the second case that they must reach the nearest street container on this side. And finally, in the brink, you have to move the ecological area. It is defined in several different words. They must to reach this point to bring their waste. Obviously, there could be situations in which one solution could be the best one according to the geographical, the morphological, also the would say the political that we have in a certain territory. Because if we have very scattered houses on a mountain, for example, it's quite difficult to have waste. It would be much more reasonable to have a bring point system or some street containers that are easy to reach, the truck, the municipal vehicle that must collect the waste. In other cases, other kinds of collection could be experimented. For example, in a city, there could be probably other problems, other issues that could be met with another system. In general, we can mental, economic, and social issues considering these three main kinds of waste collection. For example, if we think about the decrease of waste, household and similar waste, we could expect that the doorstep collection could result in the high decrease, while the street containers probably not affect this point. This is because, in general, the doorstep collection is performed by operators that the type of waste that are collected inside inside a certain territory. So it could also suggest penalties, fees for those people that did not perform correctly the separate collection. In general, with the street containers, this is not possible, apart from the case in which we have bins that could be opened only with electronic key, with an electronic key, because in this case, user can be identified by the use of some key. And the amount of waste that is generated could be quantified by the collection system. In general, the doorstep collection occurs when in different days. So the citizens served by the plastic collection in some days of the week, by the collection of bio-waste in other days, only 1 day for the collection of the mixed waste. So they are quite forced in attempting to reduce the amount of mixed waste, because they can put the mixed waste on the place in which the collection occurs only once a week. So probably this is an incentive to reduce the amount of mixed waste and in general of waste. It has been demonstrated that generally the doorstep collection is able to reach percentages of separate collection that is higher than 50%, while street containers could reach a percentage of separate collection that is lower than 50%. In general, it is not always like this, but in general, this is the result. The purity of materials could be high for doorstep collection, again, for the same reason, because operators could check inside the bins or the sacks or something like this that are exposed by citizens, and could also, and the people would pay a fee if they did not perform the separate collection properly. In general, the street containers do not allow a high purity of materials. Obviously, the use of different waste transportation systems, particularly different trucks that have we could have built plastic only, we may have a very high percentage of impurities. It is reported that 33% of impurities. These impurities, this result does not mean that we have other materials that are not plastics inside the containers. Probably they are also plastic materials, but they would not be collected together with the plastic containers, the packaging that is only type of material that could be inside this. Instead being also other plastic materials, I don't know, toys or stuffs that are not packaging, even though they are plastic materials in the table. But if we see the Bible with the role it is inside 20% with that. region. Here, the entire territory is represented according to the different, it is called according to the different managers of waste collection service. So you may see that there are many services, there were many services collection systems in Emilia-Romagna region, not properly related to each province. So they could vary according to the different provinces. This could also be, could affect the final result of waste collection, percentage of separate collection. Here are the results concerning the percentage of separate collection in the Emilia-Romagna region. There was quite a good situation in the northern part and also in the eastern one, while in the southern part, that are the municipalities on the hills and on the mountains of the region, the percentage were quite low, okay? While on the plain, the percentage were higher. In this case, this map is divided for the different municipalities. So these were the results that we collected, but we tried also to collect some indication relating to the type of materials that were inside the different types of collection. So, for example, this was the material composition on average of waste from separate collection. And you may see that there are a quarter of this entire amount is of paper and cardboard, 25%. Only 4% of the separate collection was composed by plastic. Organic and green waste, so bio-waste and green waste, were around 37% in the separate collection. And wood, for example, 11%, inert 5%, and other 8%. Let's see the composition of the entire municipal solid waste. You may see that plastic waste inside the entire municipal solid waste amounts to 12%. That is much more than 3 times the amount of plastic that we found in the separate collection. This means that plastic is usually not wrongly collected in the waste, in the unsorted waste, instead of separate collection system. While for bio-waste and green waste, the amount that was registered in the overall general composition of municipal solid waste was 30% compared to the 37% that was found in separate collection. This means that the collection of bio-waste was higher than the so it was more effective than other kinds of materials, for example, plastic, that was not properly separated. Also, wood in separate collection was present in terms of 11% compared to only 5% that was the real percentage of wood waste in the overall municipal solid waste. These were the trend of the different municipalities that were able to collect different percentages of separate collection, with an increase of municipalities reaching high percentages of separate collection, and a decrease of municipalities collecting less than 50% of separate collection. It is quite interesting to see that till 2005, there were 50 municipalities collecting less than 50% or 15% of municipal solid waste separately. But fortunately, this trend continued also in the next years, and nowadays many municipalities are able to reach very high percentages of separate collections in Emilia-Romagna. What was the aim of our research? It was of our study. It was to understand which were the parameters, the factors that affected the waste collection systems and the amount of waste that was generated by the different municipalities. So we put in different graphs, okay, different figures, all the municipalities present on plain areas, all the ones that were present in hill areas, and all the municipalities that are on the mountains in our region, distinguishing them according to two different parameters. You may say, see on the x-axis the amount of the quantity of waste generated, expressed in terms of a delta quantity, delta with respect to the average amount of waste generated by the region, overall region. On the y-axis, you may see the delta separate collection. That is the increase in terms of separate collection with respect to the median of the region that was registered in that year. But also a median centroid coordinate was identified to see the specific behavior of municipality on the plain, on the hills, and on the mountain. And we can see that on the plain there are, in general, municipalities that generate more waste than on the hill and on the mountain, but with a higher separate collection. Okay, you may see that we have some peaks of 40% of separate collection more than the regional average that was registered in that year. On the opposite quadrant, we can see the mountain, the municipalities on the mountain that had the lowest amount of waste generated, okay? Because we see that this is the average, 0% and 0 in terms of delta is the average, the regional average. We are in a place in which you can see the amount of the quantity generated per capita by the different citizens is less than the regional average, but also the separate collection is much lower than the regional average. Furthermore, we divided the different municipalities according to the density of population. And we identified rural areas, low population density, medium population density, and high population density areas, municipalities. Obviously, for the high population density municipalities, we have only few examples of cities that have a high population density, while we have a lot of rural areas. And as for the high population density, we may see that they generate per capita more waste than the regional average, and they have lower percentage of separate collection. Highest percentage of separate collection could be found on low population density or medium population density municipalities, in which the percentage is higher than the delta is higher than 0, while also in the rural areas the separate collection could occur more with some more difficulties. So, in summary, the places in which you may obtain higher performances of separate collection would be not the crowd centers, not the spared with the areas with spared houses on the territory, but those that have a density, a medium population density, in which some systems of effective separate collection could be applied. In general, we identified, according to the median values, the different categories of places, and we may see that the highest amount of waste generated per capita is the one deriving from high density populated municipalities on plain, while the highest performance of separate collection is provided by medium density areas on the hill. And in general, if we wanted to summarize the results that we obtained, we found the influence of morphological but also social characteristics in influencing the waste collection system, because waste collection is more complex and costly in mountain areas, while higher separate collection percentages are rich in plain. We didn't find any evident difference among various separate collection systems, but we found that higher impurity rates were observed if many materials were collected together. Lower density areas allows for a better control of the different users and of the single actions, so a higher percentage of separate collection could be reached. And also, finally, where a collection of bio-waste is present, better results were reached, because the organic fraction is significantly present in mixed waste as kitchen and garden or part residues at about 33%. And this was a research that was published on quite interesting and internationally recognized journal, that is Waste Management. Nowadays, we have some other kinds of waste collection, some innovative, let's say, industrial sorting systems that use, for example, artificial intelligence in order to understand which kind of material is under the optical sensor of the machine, then quite effectively similar to the way a person does. And the system is able to make multiple sorting decisions autonomously, for example, separating various materials as thermoform trays, aluminum, fibers, and removing residues from a stream of PET bottles. We can see also an example of this kind of technology in this video. That is performed by this there is a news. These are spider that recognize the weight, the single types of weight that in the different containers. If this paper on our left is plastic on our right, for example. Obviously, it is not the only step of separation. We could have many different steps of separation because some of these waste is not separated because yes, the feed belt uh, quite high, so it is possible to separate sort. Places in which also this kind of collection system is in use. It is called pneumatic collection system. So the advantage is to avoid trucks that go around the city and help to collect all the waste in different days of the week, in different hours. You simply put the waste in these sort of tubes from which the waste is sucked and transported in a collection center in which the different materials are kept separated and efficiently recovered. Obviously, the advantages are less odors, are quite interesting aesthetical result, so less visual impacts and less transportation costs because you only use the aspiration to collect the waste in different containers. The disadvantages are high implementation costs and significant energy consumptions because you may use electric energy to accomplish this system. I think that we can see also in this case a video that you may find on YouTube, so it is very easy to see it. I'm sorry, but other video started. I hope that. Okay. Okay, we can go directly to the of Okay. There are many places. I'm sorry, it is a quite promotional video, but it is only to make you see an example of this kind of technology that is quite diffused all over the world in many different cities nowadays. And so it seems that it works. So it could be applied, I think, in many different situations. Obviously, there are costs of implementation and also of energy consumption that must be taken into account. Other kinds of waste collection systems are those, for example, of underground bins, for example, that are placed in zones of high artistic value, so they must be quite far from the site of people, of tourists that are visiting the place. And they could be emptied every some days from by trucks that are able to collect the system. Here another type of system, again, probably a pneumatic system that is applied in Singapore, also to applied into high buildings or hotels, in which people can put the rubbish, the waste in suits, and all the waste is collected in these tubes and put in a centralized bin center in which it is compacted or separated according to the different technologies that are implemented. And afterwards, trucks that are filled with these waste can go towards treatment facilities. There are many air inlets to provide the pulse to push all the waste towards this centralized bin center. But in some cases, there are also the collection of materials that could be recycled. Okay. Okay, this slide, this set of slides is finished. I don't know if you want to ask some questions, if you have curiosities, some comments to do.
Yeah, I have a question.
Yes, a question.
This machine, the first machine, would it be how long does it take to do that on a large scale basis also for Italy or other countries in Europe?
The first one, this one.
Yeah.
Yes, it could be applied in different countries. I think that the best application could be for the fine separation, fine tuning, when you have assorted material, for example, plastics, that is composed by many different families. So you cannot pretend by citizens to be aware about the different kinds of plastic and so to separate in different containers the plastic. So afterwards, after the collection, maybe a machine like this would be able, according to some spectroscopic techniques, to check and to understand, to be able to identify, for example, PET, that is different from polypropylene, from polyethylene, from PVC. So the different kinds of plastic would be effectively separated with this kind of machine. And I think that also here in Italy, if I remember correctly, there is a company in Bergamo, in Lombardy, that is named Montello, that works on these kinds of machines to improve the efficiency of some materials separation. Many different examples of these kind of machines are present every year at the Ecomondo Fair here in Rimini. So if you wanted to see some examples of this kind of techniques, probably by visiting the fair, you may see different examples. Okay, thank you. And I wanted to now to present with another part that is the first example that we may discuss together of an LCA of a product. And since we have discussed about the different kinds of plastics, this could be a good example of application of LCA, because it was applied to two different kinds of plastic bottles. The first one that you may see on the right is the classical PET bottle. PET means polyethylene terephthalate. It is a particular polymer that is widely used for these kind of applications. The other one is PLA, polylactic acid. This study was performed about 10 years ago. So other studies were performed after this one. But I think that this kind of study would be particularly representative for the assumptions that they made, the two investigators, and also the type of presentation of results that will be interesting to discuss together. But first of all, let's stay some minutes on the definitions, because you may probably have heard about ecological polymers. Ecological polymers, however, is not a unique definition, a univocal definition, because it could include a lot of different kinds of materials. In some cases, sometimes this definition is applied to the polymers that are generated, that are produced by renewable raw materials. Okay, so from biomass. And in this sense, we may have three distinguished types of ecological polymers from renewable raw materials. There are natural polymers directly formed by biomass, for example, cellulose. Cellulose is a natural polymer. And we know that also paper is a sort of polymeric material. However, the cellulose is a natural material that is formed directly by plants and not by humans. And so we do not need any synthetic chemical process to obtain these kind of polymers. There are instead polymers that could be formed from biomass, particularly from biomass monomers, that, however, need a synthetic process to be formed, to be produced. This is the case of PLA, the case that we are now investigating. It comes from the lactic acid that you may see on the left. This is lactic acid. Probably you know that also we produce lactic acid when we make gym. For example, we make sport. But in general, can derive from a digestion process that is mediated by microorganisms. This could be converted into a lactide, that is an intermediate molecule, and finally transformed into a polymer, that is this poly 3,6-dimethyl 1,4-dioxane 2,5-dione. In brief, PLA. Other kinds of polymeric materials are synthetic polymers from synthetic monomers deriving from biomass. What does it mean? For example, you may know that bioethanol comes from the fermentation of many different kinds of materials, not only I mean, there are many biomasses that are transformed into ethanol according to the availability in the different countries. Sugar beet, or I don't know, many other kinds of materials. The bioethanol can be transformed into bioethylene, okay, ethylene, that could be transformed in polyethylene. So the bioethanol comes from biomass, but the final result is perfectly identical to the polyethylene that could be produced from crude oil, okay? So they are synthetic polymers from synthetic monomers deriving from the transformation of the biomass. But there is another definition that is commonly used, bioplastic. Again, this is ambiguous because it could refer to renewable materials used as raw materials. So again, for example, the cellulose, again, okay, biodegradable or compostable materials that is different from the previous definition. To be biodegradable or compostable means that at the end of life, you may be transformed by processes that occur naturally, I would say, by natural organisms. But this is different from the renewability of the materials. Some examples. The polyethylene that comes from bioethanol derives from a renewable source, but cannot be degraded or composted at the end of life. Okay, so there is a renewability of materials, but not at the end a compostability of the material. On the contrary, a material could be biodegradable, but from non-renewable sources. That means that it comes from oil. We have biodegradable polymers from oil. For example, this beta-caprolactone that is used in surgery, for example, for the wires that must be absorbed by the body. So they must be biodegradable, but they are not produced from renewable materials. They are produced from synthetic materials, from oil. Which are the application of these bioplastics? For example, the containers for the recovery of organic waste and shopping bags. In order to dispose of our bio-waste, we can put it into the bags, organic, compostable bags that at their end of life could be put in the same composting plant. But there are other applications, for example, cover films for applications in agriculture. At the end of life, these films, covered land, could be left on the ground because they could be transformed naturally into humus, into compost, without any human intervention. So with respect to other kinds of materials, for example, PVC films, they have the advantage of that will be kept over the land without any removal. Products for catering to collect food residues. Maybe you have seen compostable materials like this that could be used, for example, in some parties, something like this, to avoid the separate collection of food residues and of the other containers, the other parts of that has been used. We can put all together into the bio-waste container. Also, beverage containers have been produced in other, let's say, biopolymers, something that could be composted at the end. Maybe I think that you all know what is the composting process. It is a transformation. We will see what is when we will see the transformation of bio-waste, but in brief, it is a process that transforms bio-waste into something that is similar to humus, to soil, something that could be used as a fertilizer on the soil. Okay, so at the end of life, also this bottle could be composted. Okay, and could be transformed into something that could be spread on the land, on the soil. There are also special products, as I said before, for example, in the medicine, biomedicine, that can be used, and they are absorbed by the body. For example, this kind of wires that are in caprolactone. Okay, so let's see the example that we wanted to investigate, to analyze. What is the first step of a life cycle assessment procedure? The goal and scope definition. Goal and scope definition means that, first of all, we have to define the unit that we wanted to analyze, and also the boundaries of our analysis. Let's start from the functional unit. If we wanted to compare two different kinds of bottles, okay, we made the same examples when we discussed about the study of Coca-Cola in the late 60s of the past century. If we wanted to compare two different containers of water or of beverage, we may consider the same volume that is inside the bottle. That is the functional unit, not the amount of aluminum or glass or plastic. And also in this case, the functional unit is defined as 1,000 units of half-a-liter bottles to be used for drinking water. From the functional unit, we may define a reference flow. The reference flow is something that is related to the functional unit and identifies quantitatively the amount of materials that are considered for our case study. For example, in this case, we have 12.58 kilograms of polymer granules to produce 12.2 kilograms of bottles, both for PLA and for PET bottles. In this case, the authors assume that the weight of the two different polymers is the same. Okay, so it is different from the case that we mentioned in the past, in which we had a glass container or a plastic container. In that case, the weight of the different containers was different. In this case, we have two different plastics, but we can assume that more or less the weight is the same. In fact, they consider that the differences in the mechanical characteristics of the two kinds of polymers do not justify any difference in the bottle thickness and therefore in the bottle mass. Okay? So they consider that both polymers have the same weight, the same density, so the same mechanical characteristics. Again, if we wanted to mention or the assumption that we made, first of all, we must consider that we have different qualities of data if we consider PET bottles and PLA. Why? Because PET polymer is the result of a mature technology, extensively tested and optimized, both for production and recycling processes. We are very expert in the production of PET polymers and also in the recycling of the PET bottles, of PET in general. PET is one of the most effectively recyclable materials, polymers, while PLA is at an early stage of development and its production is still very limited. I don't know if you are aware about brands of water bottles that are found in PLA instead of PET. Do you know some brands that use PLA bottles instead of PET bottles? I don't know. I remember one brand in Italy that makes use of PLA bottles, but it is the only one that I know. All the other companies use PET bottles for the distribution of water. So this kind of material, PLA, is at an early stage of development. And also, its recycling is not performed until now, okay? Because at the end of life, PLA is thought to be composted instead of recycled, okay? Because it is a compostable material, it is not thought to be recycled. The study is a cradle-to-grave LCA. What does it mean? It means that we must take into consideration all the life cycle steps from the extraction of raw materials to the end of life of these materials, of these bottles, okay? So these are the main assumptions that we must take into consideration. System boundaries, they include the polymer production, so from the crude oil extraction for the PET. In the case of PET, we have to extract crude oil, while for PLA, since it comes from biomass, we must consider a crop farming, okay? There are two different sources of raw materials in the two cases. We must include the transportation of polymers to the bottles production plant, assumed 100 kilometers by rail. We must assume injection molding and blow stretching of bottles that are the production process to obtain a certain shape also of the bottles. And finally, the waste collection, sorting and treatment of used bottles. Which kind of waste treatment? For both polymers, incineration and mechanical recycling, and landfill. Only for PLA, composting, obviously, because PET cannot be composted, while PLA has been conceived to be composted. Other kinds of assumptions are these. Not included the retail of the bottles, production and transport of secondary and tertiary packaging, production and transportation of the infrastructure and their maintenance, and the cutoff, the limit under which we do not consider some flows, is 5% of input materials as referred to the functional group. And here, for the software database, and type of methodology of impact assessment calculation are indicated. Okay, may stop for some minutes, unless you have some questions. Okay, so we can stop and we start again at 11:15.
Fortunately, I have to go. I have to catch up.
Okay,
But we'll see you next year.
okay, thank you, bye-bye. Okay, if you agree, we can start again with the last part of this lecture. And I share my video, my screen. Okay. Okay. See the system boundaries that we have in this in this scheme. We are comparing, as I said before, we are comparing two different kinds of bottles. The first type of bottle is the common bottle or in PET, that is polyethylene terephthalate, sorry, while the second one is PLA, that means polylactic acid. You may see the scheme of presentation that starts with the raw material production. This is there is a typo here. Extraction and refining of crude oil. The extraction and refining of crude oil is necessary to obtain the granules of polyethylene terephthalate in an amount of 12.58 kilograms. The corn farming and the wet milling is something that is related to the production of PLA granules in the same quality, in the same quantity. Afterwards, we have transportation of this amount of granules. We have similar production processes for different bottles. We have 0.38 kilograms of process wastes. Furthermore, we have 12.2 kilograms of bottles that are sold, that are sent to the market and to consumers. Finally, the transportation after the use bring the bottles to the waste scenarios, different waste scenarios that we will analyze in detail. These are the boundaries, and inside or outside the boundaries, we have different flows. As you may see at the bottom of this scheme, we have wastes that are generated and that must dispose of in some place, for example, landfill or incinerator. Emissions to air and water, okay? But see, these are the inflows that are water, resources, and CO2. My first question is, why do you think that CO2 was put as an inflow instead of an outflow? Probably CO2 towards the external, the part of the system could be inserted in these emissions to air and water. But what explanation you have for the CO2 flow that goes inside our system boundaries? What is your opinion? Have you got some ideas to explain this this strange flow of CO2 inside? Have you got an idea? No, what do you imagine?
Maybe because CO2 is part of chemical processes.
Well, not exactly, because yes, it could be if we took into consideration, for example, the sparkling water, but in this case, this is not the case. There is another explanation for the CO2 inside our system. It is particularly related to the PLA production, because when we have the growth of our biomass, in particular corn in this case, the CO2 of the atmosphere is absorbed in the in our biomass, and so we have a sort of CO2 flow that comes from the atmosphere and goes into our raw materials, okay? That are the materials in which the bottles are composed of, okay? So this is the explanation of the inflow of CO2. Which kind of categories could we take into account? Eco indicator 99 is a life cycle impact category methodology that I already introduced you last time, and suggests 11 impact midpoint categories that are carcinogens, respiratory organics, that are organic compounds that cause respiratory diseases, respiratory inorganics, climate change, radiation, ozone layer, toxicity, acidification, eutrophication, land use, minerals, and fossil fuels. If we group these 11 impact midpoint categories, we could obtain 3 endpoint categories, or macro categories, or damage categories, that are human health, ecosystem quality, resources. Maybe you remember that last time we discussed about this grouping of categories of damage or of impact. But now we have the second step of the life cycle assessment methodology. After the first one, that is goal and scope definition, we have to define an inventory of the different cycles that we take into account. So for the inventory, we must define the data quality, the allocation procedures, and the uncertainties that we have in our data. First of all, where do we obtain data that are useful for our investigation? The two researchers say that there is a lot of information for PT, particularly provided by the European plastics industry, an association that includes almost all industries that deal with the plastic production, while for PLA we have available only one article. There is a great difference in terms of data quality between these two materials. PT is widely known, while PLA is at an early stage of development, and so it is very difficult to understand, to have reliable data about PLA. Second, since PLA is produced from corn as a raw material through fermentation processing, and there are other co-products, not only corn that could be transformed into lactic acid. The co-products are, for example, corn meal, okay? So we have two products with the same process. How can we proceed? We must allocate the environmental impact considering both or more than one final products. In this study, the allocation procedures have been carried out via mass. Okay, the mass of corn meal compared to the mass of the residues of corn that are transformed into lactic acid. If it is the same mass that can be transported in meal and the same mass that can be used for producing lactic acid, we can distribute 50-50 the impact, the environmental impact of the production, the growth of corn in both directions. Reliability of results. Uncertainties are associated with the choice of PLA and PET inventory data and the several model assumptions made on the disposal scenarios. We will see that we have several disposal scenarios and we must make some assumptions on the different destination of our final materials. There are other uncertainties that derive directly from by the oriented damage approach. That is the transformation that we discussed last time, transformation of physical-chemical data into ecological data that are, for example, climate change, eutrophication, acidification, but even more, the transformation of these midpoint categories into the endpoint categories, because we must transform something that is related, for example, to the emission of CO2 or CO2 equivalents into something that has effect on human health, for example. Okay, so these uncertainties could be very high. And finally, authors say this work can be useful to draw first considerations, but cannot be taken as guidelines for the market use of PET rather than PLA bottles and vice versa. So they do not want to provide final conclusions on the preferability of PET rather than PLA. They only wanted to draw first consideration. Okay. We have said that PET and PLA are different materials and they must be differently treated at the end of life. So what can they undergo at the end of life? They must be transported from the place in which the waste is generated to the place in which the waste is treated. And the transportation has been carried out with diesel vehicles for the transportation of cargo over 16 tons. It is a quite usual assumption, for an average distance of 100 kilometers, taking into account that used bottles transportation to the sorting plant and then to the waste treatment plant. Okay, so they consider both transportation. As for the incineration, we may assume that we can have 30 megajoule of electric energy plus 61.4 megajoule of heat by burning PET. While if we consider the burning of PLA, we may obtain 26 megajoule of electric energy and 53.3 megajoule of heat. Why, I ask you, why do you think there are these differences for the two materials? While different values, are considered for the incineration of two materials. While is it higher for PET rather than PLA, the number of electric energy produced and heat, thermal energy produced? What is the reason of this difference? The reason is the different calorific value that is intrinsic, is related to the different materials. Because PET is combusted better than PLA. produces more energy than PLA, okay? It is a better fuel if we want to compare the two different materials as they were fuels, okay? It is a better fuel, PET, than PLA, and delivers a higher amount of electric energy and of thermal energy. Okay, since we obtain a certain energy recovery from the combustion of such a kind of waste, we can displace these recoveries from the energy consumption that we have in the step of granules production. Okay, imagine that we have some electricity consumption in the production of granules production. We can think that the energy recovery that we can have at the end of life by burning that material could be used to replace the energy that has been used previously for granules production. Okay? The emissions in water and air are also taken into account related to sludge treatment and ash disposal in landfills. As for the landfill, we will see some, in particular, some typical plants that host waste, like landfills. As for landfills, we have a collection of leachate, that is the water that is generated by the degradation of waste. Leachate and process in a water treatment plant. Okay, the leachate is sent to a water treatment plant. There is a degradation of PET very, very low, because PET is something that is very difficult to degrade. There are many researchers that are devoted to identify microorganisms that are able to degrade the PET, but nowadays it is still quite difficult to obtain a degradation with microbiological assisted processes. So at the end, in 100 years, we can assume that only 1% of PET is degraded, while PLA can be degraded, because PLA is a degradable material. So we may think that 85%, this is the assumption that has been made by the authors, 85% of PLA can be degraded in anaerobic conditions. What does it mean, anaerobic conditions? Means not aerobic conditions, okay? Because in the landfill, when you put all the waste in different layers over the previously deposited waste, you may induce anaerobic conditions at the bottom of this landfill body. So since there are anaerobic conditions for PLA, there is a production of biogas. You know that landfills usually produce a biogas that could be recovered, okay, aspired and recovered with a low efficiency, about 25%. And this biogas usually is transformed into energy with a certain efficiency. In this case, it is quantified as 36% of efficiency. Also in this case, if we can recover energy, we can displace the grid and electricity for the polymer granules production. Composting. The composting is a process that can take place only for PLA, for the reasons that we have explained before, because PLA is a degradable polymer, while PET is not a degradable one. So what is the degree of degradability of PLA? Authors assume 60% of degradation of PLA, while the other 40% is divided between biomass, humus, and recalcitrant residue that has not been completely biodegrade. 95% of C, that is carbon, evolves in CO2, while the remaining 5% in methane, assuming the presence of small anaerobic pockets inside the pile that is going to be combusted, okay? But think about these two figures. Do you remember what is the greenhouse factor, the equivalent factor that can be considered for methane if compared to CO2? 1 kilogram of CO2 equals how many kilograms of, 1 kilogram of methane, CH4. How many kilograms of CO2 is equivalent to? You remember?
Around 30.
Yes, maybe
It was,
less, but okay. Yes.
it was 22.
Yes, there are many estimations. We can range from 21 to 28, more or less. So think about 2020. Let's think about 20. That is the lower estimation that we could have. 5% of methane multiplied by 20 means that it could equal 100% of CO2, okay? So in this sense, 95% of gas that derives from the composting process of PLA, 95% of CO2 affects less than 5% of methane, the category of global warming, okay? Because the power of methane, of the greenhouse power, let's say, is higher, much higher than CO2. So even though it is produced in a very lower extent, its contribution to the greenhouse gas is higher. And finally, recycling. Recycling is surely the most virtuous, we could say, type of treatment for these kinds of materials. But the recycling could happen for PET bottles, because we know that there are many industrial processes that deal with the recycling of PET bottles, and the efficiency of recycling is around 90%. This means that 1 kilogram recycled bottles produces 0.9 kilograms of granules that could be transformed again into PET bottles, for example, or PET materials. This means that we have a loss of about 10% of materials that is unavoidable, okay? But this is a very good result that we can have in recycling, and only for PET, while for PLA, we haven't any information about PLA. So the two researchers assume the same, in a conservative perspective, assume the same for PLA. So they assume that also PLA could be recyclable, and that could replace 90% of a new material. So it has been assumed that all the recycled polymers are used for the production of new bottles. Energy requirements are also considered. Okay, so finally, we can give a look to some data, some results. PLA results in terms of different midpoint categories, impact midpoint categories are reported in the first table. In the second table, we have all the results concerning PET. So what can we see? We can see that we have different steps of life cycle. Sorry, first of all, sorry, I forgot to say you that the two authors apply the investigation of LCA by considering two steps. One is from cradle to gate, that means to the gate of the production. The second is from cradle to grave, okay, to the end of life. Cradle to gate, so let's think only about the production of these bottles. From the production of granules, that is the first step, the transportation of granules to the facilities that obtain the final shape of the bottle, of the bottles, and so they produce the bottles. As for the different categories, we can notice that global warming potential for PLA is much less than the global warming for PET. Have you got any explanation for this significant result that we have? The first row for the PLA and the first row for PET that refer to global warming potential in both scenarios. Have you got an idea to explain the difference between the two values, 17 point something, 38 point something kilograms of CO2 equivalents for 1,000 bottles? What could be the explanation? Why PLA is much better than the other one for the global warming potential? And particularly, you may notice that the greater difference is on the first step, because of the transportation has the same impact for both scenarios, and also the bottle production more or less has the same impact. The great difference is on the first step, on the granule production. The difference is that for PLA, we have a biomass, the transformation of a biomass into a final product in plastic, okay? While for PET, we have fossil fuels that are transformed into polymers. So in this case, obviously, we will have some fossil fuel consumptions for all the energy requirements of this production of granules. But we may subtract all the CO2 that is fixed by the biomass, that is absorbed by the biomass in its growth, okay? So in this sense, this number is the resulting amount of CO2 by summing all the processes that emit CO2 in the atmosphere, into the atmosphere, minus all the processes of absorption of CO2 that is related to the biomass growth. Okay? I hope it is clear. While for the granule production, in the case of global warming, we have only emissions of CO2 into the atmosphere without any absorption. Okay. Let's see the last two numbers, last two rows, acidification and eutrophication. In both categories, no, let's see only the last one. Eutrophication potential. Yes, they are both in the same order, so we can consider both. You may see that, for example, PLA production has 145, more or less, grams of CO2 equivalents, while for PET we have only 170. As for the eutrophication, the amount of nutrients delivered into the environment, we have 94 grams of phosphate equivalents for PLA and only 37 for PET. Again, could you explain this difference? Why? In this case, for PLA, we have greater impacts rather than PET. In the case of global warming, we have the lower impact for PLA, okay? In the case of acidification and eutrophication, we have the highest impact for PLA instead of PET. Why, in your opinion?
Maybe because to produce like the biomass, you need to use fertilizers.
Okay, okay. Good answer. Yes, you may use fertilizer, you may use probably also pesticides, something that could affect the quality of ecosystem in the land, okay? So you may affect the impact categories of acidification and of eutrophication, because you may add the nutrients into the land if you wanted to have a growth of a significant amount of biomass, okay? That does not happen for PET, okay? Okay, let's see a graphical representation of the two scenarios. In this figure, you may see the different impact categories: carcinogens, respiratory organics, inorganics, climate change, radiation, ozone layer depletion, and so on, with a pairwise comparison of PLA and PET. The material which has the highest impact is represented with the highest bar until 100%. The other material is represented in a relative form, that is the percentage of the highest impact that is related to the second material, okay? So for carcinogenic substances, we have again PLA that provides the greater impact. Okay, 100%, if we put 100% of the impact of PLA, we would have more or less 60% the impact of PET. Again, surely this is connected with the use of pesticides, okay, for the cultivation of corn that have some carcinogenic, could have some carcinogenic consequences. Let's see some other examples. For example, climate change shows the opposite result. We have the highest amount of emission of climate changing gases for PET. We have seen it before. And while the amount of climate changing gases in a perspective from cradle to gate, we do not consider the end of life of these materials at this step, is much lesser for PLA, is around 40%. Obviously, if we see land use, there is a dramatic difference between the impact of PLA and the impact of PET. Why? Because for the cultivation of corn, we need a lot of place of land that is converted to the cultivation of a devoted biomass that is used for chemical purposes, we could say. While in the case of PET, the land use is very limited. It could be limited to the facilities that we have to use for the transformation of our monomers in polymers, for the blow stretching, so the final production of bottles. But the land occupation of PET is much lower than the land occupation that is required by PLA. Okay? Obviously, the opposite appears for the fossil fuel consumption. It is much higher in the case of PET because we rely on fossil fuel in the case of production of PET, while PLA has a part of raw materials that comes from natural processes of biomass growth. Okay, is it clear? I hope yes. Okay, but my question is, again, we notice that there are different midpoint categories in which the PLA performs better than PET. But there is probably the same number of categories in which the opposite happens, in which PET performs better than PLA. So, what is finally the conclusion? What could we prefer between these two materials if we want to suggest to the decision makers, to the politicians, the best perspective for our future? What could we suggest if we have so different kinds of results in the different categories? Okay, because there are categories in which one material could be preferable and other categories in which the other could be preferable. So the solution could be to group the different midpoint categories into endpoint categories, okay, according to the algorithm that we explained last time. Let's see which are the results coming from the application of this grouping technique to the two scenarios. Human health. As for the human health, we have a lower impact from the use of PLA and a higher impact from the use of PET. The opposite occurred for ecosystem quality, probably because the ecosystem is largely more affected by the cultivation of corn to obtain PLA rather than by the production of PET, because it has a low requirement. It has low requirements of land to be produced. And finally, resources is the final group for which we can say that PLA shows lower impacts, lower damages to the resources compared to the damages that are provided by PET. Again, we are in trouble because PLA is the best one among between the two for human health and resources categories, but not for the ecosystem quality. So, what to choose in these conditions? Again, we have the same uncertainty as before, as we have seen before. Here we have many different impact categories. Here we have only 3 damage categories, but the problem is the same. There are some categories in which one material is the best one, and another category in which the other material is the preferable one. This is why we could introduce a weighting process to obtain a final single score that allows us to compare univocally the two different materials, okay? Because obviously, if I think that the ecosystem quality has the highest importance, I have to prefer PET instead of PLA, because it is surely evident that the ecosystem quality is much more affected by PLA rather than PET. I could conclude the opposite if I think that the human health or resources have the highest importance in my consideration, okay, in the consideration of the future development of the technology. So if I prefer to safeguard the human health and the resources, I will prefer PET bottles. If I wanted to consider the highest importance of the ecosystem, I would prefer PET instead of PLA. Okay. So again, we must try to use a unique impact index that weighs the different categories into only one single score. I think that now we have only 2-3 minutes to the end of the lecture, so we cannot introduce another concept. So I would stop here. I will finish on the next hour of tomorrow, but I'm available if you have any questions until here to ask me, or some suggestions, some discussions that you want to introduce. There are questions? Is it all clear? No question from Abdul Rashid?
For the moment, it's okay. No questions. Thank you.
Okay, okay. So, goodbye, and see you tomorrow at 9, okay? Goodbye. See
Thank you. Bye.